Hello, good morning to all of you. I hope all of you are doing well. So in today's class, what we'll learn about various software lifecycle models. We'll be describing each of these software lifecycle model, taking into consideration its characteristics, the set of advantages and disadvantages it has, and its applicability. Now, let us start with the first software lifecycle model that is called as build and fix model. Now, build and fix model is also known as an ad hoc model. Here, what we do is we build the first version of the product, and then the first version of the product undergoes continuous change until unless the product does not meet the expectation of the customer. Now, this particular model is generally applicable in situation when the problem size is relatively smaller, in order of hundreds source lines of code. So here, one of the important aspect that you need to look for is that build and fix model tries to refine the existing system when the system is actually in operational mode. So when the system is actually performing the task, it tries to refine the system so that it meets up with the expectation of the customer. Now, as build and fix model is a very simple and ad hoc model, no proper documentation is created in case of build and fix model. Now, let us go through the advantages of build and fix model. Now, the only advantage of build and fix model is that this particular model comes in very handy in situation where the problem size is very small. As I've already said, if the problem size is in between 100 to 150 source lines of code, then build and fix model comes in very handy. But it has a host of disadvantages. The first disadvantage is that build and fix model is not suitable for problem of larger size. Now, in the second disadvantage is that if there is an improper design being constituted as well as the requirements are not properly drawn, then the cost of executing the software lifecycle model or executing this software lifecycle model increases unexpectedly, or there is an exponential growth in the cost. Now, maintenance of the product developed using build and fix model becomes very difficult because no proper document is created whenever build and fix model is executed. Likewise, no rework can also be initiated because there is no proper documentation. So, in such situation, what you need to do is you need to reverse engineer and then you need to forward engineer in order to redo certain amount of work in the product developed using build and fix model. Now, to overcome this particular problem of build and fix model, a model was proposed and it was named as classical waterfall model. Now, the classical waterfall model, as it is alternatively also known as original or conventional or traditional waterfall model, is named so because it resembles cascades of waterfall. The various phases in the life cycle model resembles cascades of waterfall, so that's why it's called as a waterfall model. Now, classical waterfall model has various life cycle phases in it. The life cycle phases are feasibility study, requirement analysis and specification, design, coding, unit testing, integration and system testing, and maintenance. Now, again, I'll repeat it. The various phases in classical waterfall model are feasibility study, requirement analysis and specification, design, coding, unit testing, integration and system testing, and maintenance. Now, the various phases that are extending from feasibility study phase to integration and system testing phase is called as development phase, because these are the phases when the actual development takes place. I'll repeat it. The phases that are extending from feasibility study phase to integration and system testing phase is called as development phase, where because in during these phases the actual development takes place. Now, the phases that extends from feasibility study phase to delivery of the product is called as development part, because delivery of the product is not a development phase, but it is the part of the, or it's the responsibility of the developer. So that's why it's called as development phase. So students always remember that you need to be able to differentiate between development phase and a development part. Development phase extends from feasibility study to system integration and system testing, whereas development part extends from feasibility study to delivery. Now, this is a very simple pictographical representation of the various phases that are there in classical waterfall model. So here what we have is we have feasibility study phase. We have requirement analysis specification phase, we have design phase, we have coding phase, we have testing and maintenance. But in addition to these 6 phases, you may find that there are 2 phases which are called as planning and deployment, which are placed separately. You won't be finding this planning and deployment explicitly represented in literatures, but here I've included it because these are 2 implicit phases that are executed after requirement analysis and specification and testing phase respectively. So planning phase is executed after requirement analysis and specification phase, whereas deployment phase is executed after testing phase. Now, here are the few notable advantages of a classical waterfall model that you need to go through. So, first advantage is that it's very easy to use because it's a very simple linear model. So, it's very easy to use and it's very easy to understand. Now, in case of classical waterfall model, each and every phase has a set of well-defined input and output. Input and output, that is, it has a set of well-defined entry and exit criteria, so assessment becomes very easy. Now the third important factor is that it is very easy to use software development process because it's very easy to understand. Now the fourth advantage is that, as I've already said, each and every stage has a set of well-defined deliverables or project standards. So since there are entry and exit criteria associated with each and every phase, so it calls for generation of project standards after each and every identifiable phase. Now, the fifth advantage of this particular model is that this particular model enables proper planning of the project. Proper planning of the project because this is a very simple linear model and it allows or it facilitates the project manager with proper planning. Now, the next advantage of using this particular model is that it provides a very suitable template for analysis, design, code, testing, and support. The other advantages are it works well with situation where the quality demands are dominant over the cost and time. So in situation where the customer demands for the quality of product without compromising on cost and schedule, then this particular model comes in very handy. Now, this particular model comes in handy in situation where the defects are identified very early in the software lifecycle phase. Now, this life cycle model also provides a very suitable or a concrete structure that enables efficient staffing. So these are the few notable advantages of classical waterfall model. So let us highlight a few of the disadvantages as well. Now you must have observed in case of classical waterfall model, there is no provision of going back from any of the downstream phase to any of the upstream phase. That means if a phase is if a phase is completed, then there is no provision of going back to that particular phase or revisiting that particular phase. Now this is one of the major disadvantages of classical waterfall model that makes it a theoretical model rather than a practical model. Because in a real world situation, it may so happen that the requirements may continuously change. Now, the second disadvantage of this particular model is that this particular model has non-overlapping phase. That means there is minimal or no interaction between the various identifiable phases that are there in the software lifecycle model. Now, this particular model allows for very less interaction between the members of the project team, which is not desired. Now, after the development process starts, then this particular model does not allow for any or accommodate any change. Now, this is one of the biggest disadvantages of this particular model. Now, this particular model does not support delivery of software application in pieces. So this particular model also comes or is also not found suitable in situations where the requirements are not completely specified. Okay. In this particular model, customer gets to review the product very late in the software lifecycle model because there is minimal participation of the customer during the development phase, which may increase the risk of failure. So all of these aspects of classical waterfall model makes classical waterfall model a very rigid model and a very theoretical model rather than a practical model. Now, in order to overcome the lags of classical waterfall model, a new waterfall model was proposed, and it was called as modified classical waterfall model or iterative waterfall model. Now, one of the major lag of classical waterfall model, if you have seen or observed, is that it does not allow for any feedback path for going from any downstream phase to any of the upstream phase. Now, in order to overcome that, modified classical waterfall model incorporated a feedback path that allows for one to go from any of the downstream phase to any of the upstream phase. Now, just see, this is a very simple pictographical representation of iterative waterfall model, where with the associated life cycle model, what you have is you have the feedback path that allows for one to go from any of the downstream phase to any of the upstream phase. So if you have encountered a problem during coding phase that is in relation with the design phase, then what you can do is you can use the feedback path, you can go back to design phase, bring about a rectification, and again continue further. So this was one of the biggest achievement of classical iterative waterfall model that allowed for correction if required. Now, what are the advantages of classical modified waterfall model are? So this is a very better model compared to that of classical waterfall model, and it's a rather practical model that we have. It allows for feedback paths, so which from using which what you can do is you can go from any of the downstream phase to any of the upstream phase, which makes it rather not very rigid. Now, this particular model can be perceived in situations where the requirements are not well understood before the onset of the development phase, which in contrary to classical waterfall model is not true. Classical waterfall models demands the requirements to be well understood before the initiation of the development phase, which is rather not true in case of a modified waterfall model. Now, there are a few notable disadvantages of iterative waterfall model or modified waterfall model. These are it's a very difficult model to it's a model that's very difficult to handle, because as the use of the feedback path increases, then it may be very difficult for us to manage the complexity of the overall software lifecycle model. Now, as there is a feedback path, then if there is no adherence to the entry and exit criteria, then no clear milestone may be achieved in the development process, and it may so happen that none of these stages are really finished. Now, let us come to the applicability of the waterfall model. Because of its various weaknesses, application of waterfall model should be limited only to a situation where the requirement and the implementation of the requirements are very well understood. So if the set of requirements are very well understood, then only waterfall model can be pursued for developing software application. Now, likewise, waterfall model can be used only in situation where the requirement definition is very stable and is not subjected to change. And classical waterfall model comes in very handy in situation where you have experience from the past of using the life cycle model for developing similar products. So if you have been developing similar products in the past using the life cycle using the waterfall model, then in this kind of situation, what we can do is we can use waterfall model for developing application. Now, the next model that we have is called as prototyping model. Now, prototyping model tries to overcome the lag of the modified or iterative waterfall model, where increased use of the feedback path may increase the overall complexity. So here, in case of prototyping model, what we have is we have the feedback restricted only to the requirement engineering phase. So in case of prototyping model, initially a prototype is created of a system, and the prototype is assessed by the customer, and continuous refinement to the prototype is done until unless the prototype is not accepted by the customer. So I'll repeat it. In case of prototyping model, a initial prototype of the system is created, the prototype is assessed by the customer, and the prototype is continuously refined until unless the prototype is not accepted by the customer. Now here, the feedback from the customer is taken only in situation when the prototype is being built and not the development of the actual system. which differentiates itself from the modified classical waterfall model or iterative waterfall model. So in iterative waterfall model, feedback is allowed throughout the life cycle model, but in case of prototyping model, feedback is allowed only during the prototyping phase. Now, based on the orientation of the prototyping model, there are two types of prototyping model. One is called as the exploratory prototyping model, and the other one is called as the throwaway prototyping model. Now, the objective of exploratory prototyping model is to work with the user to explore their requirements and deliver a final system. Now, in case of prototyping model, in case of exploratory prototyping model, is that in case of exploratory prototyping model, what happens is that the initial prototype that is being built is refined into the actual system. Again, I'll repeat it. In case of exploratory prototyping model, the initial prototype that is being built is defined into an actual system and delivered to the customer over a period of time. Likewise, in case of throwaway prototyping model, the prototyping phase is used in order to understand the customer's requirement and to create a very suitable definition and complete and concrete and suitable definition of the system. Once the definition of the system is suitable definition of system is created, then the definition is used to create a new system. So in this case, the prototype is not refined into the actual system, but only the knowledge acquired is used in order to create the actual system. So that is the way how we differentiate between exploratory prototyping model and throwaway prototyping model. Now, this is a very simple pictographical representation of prototyping model. So here what we have is we have initial requirement gathering phase, and then we have prototyping phase, then requirement specification, then the actual development, requirement specification, design, coding, testing, and maintenance. Now here, in case of prototyping model, first the requirements are gathered, then a quick design is being made, then a prototype is developed, the customer evaluates the prototype, and the customer, if not satisfied, the prototype is refined and the process is repeated. The process is repeated until unless the prototype is not accepted by the customer. So once the prototype is accepted by the customer, then the actual development starts. Now, exploratory prototyping model extends from initial requirement gathering phase to maintenance phase. So all the phases are there evidently present in case of exploratory prototyping model. Whereas in case of throwaway prototyping model, only the knowledge acquired during requirement engineering phase is used in order to engineer a product. Now, these are the phases that are there in case of throwaway prototyping model. That is, phases extending from requirement specification to maintenance. Now, what are the advantages and disadvantages of prototyping model? Are the first advantage of a prototyping model is that a partial product partial product is initially built, or a partial prototype is initially built, and the customer gets the experience of the product very early in the life cycle phase. Now, this is very much important. The customer gets to experience the product very early in the life cycle phase, and thus it enables a feedback mechanism to work appropriately. Now, the second advantage of using prototyping model is that if you use prototyping model and if you create prototype, then requirement becomes much more cleaner, resulting in the accurate product. Now, the third advantage of prototyping model is that prototyping model easily incorporates new requirements, or it allows for refinement in the scope of the system. Now, the fourth advantage of prototyping model is that it's a very flexible. It has a very flexible design and a development mechanism because it is capable of readily accepting changes that are proposed by the customer. Now, the disadvantages of prototyping model are if a prototype is created in a hurry, then it may so happen that the prototype may not be capable of satisfying customers' requirement and may be rejected by the customer. So if the prototype is rejected by the customer, there is high probability of the actual system being rejected by the customer. So this is one important fact that we need to look upon whenever we are using prototyping model. Now, the second disadvantage of prototyping model is that by early assessment of the prototype, the customer may be expecting the product very early. which may not be true because development of prototype, the time required for development of prototype and the time required for development of system is completely different. So there is relatively lesser amount of time required for development of prototype, whereas development of the actual product takes considerable amount of time. Now, the third disadvantage of using prototyping model is that the prototype, as it resembles the system, the user or the customer may not be able to differentiate between the prototype and the actual system, resulting in devaluation of the actual system. So these are the few notable disadvantages of prototyping model that needs to be looked into. Otherwise, it's a very handy model reused for developing application. Now, the next model that we have in hand is called as V-shaped model. And a V-shaped model here, the V stands for verification and validation. So, in case of V-shaped model, what we have is we have verification and validation phase associated with each and every life cycle phase. In contrary to the other models that we've discussed till now, waterfall model or prototyping model, none of the models have verification and validation phase associated with each and every phase that are there in the lifecycle model. Now, verification and validation is very much important because it ensures that the correct product is being developed during the lifecycle phases. Now, the various phases that are there in a V-shaped model are the first phase that you have is project and requirement planning. So, project and requirement planning is a phase that is purely dedicated for determination of the various requirements and the resource allocation to the requirements. Now, the next phase that you have is called as product requirement and specification analysis. In case of product requirement and specification analysis, each and every requirement requirement that you've identified in the previous phase are precisely specified and are precisely specified or completely specified, and the expected behaviors from the system are built, are created. And the third phase that you have is architecture or high-level design. We have already studied architecture or high-level design in the previous class. Again, we'll repeat it. So in case of architectural and or high-level design, what we tend to do is we tend to identify the functionalities and the relationship between them. Functionalities that are to be implemented and relationship between them. In case of detailed design, what we tend to do is we tend to identify the algorithm and the data structure that are to be selected for achieving the functionalities that are identified during architecture or high-level design. Then you have coding phase. In case of coding phase, the functionalities that are identified during architectural design and the algorithm that are selected are realized in the executable code using suitable data structure. Then the individual functionalities are unit tested, followed by integration and system testing that determines the interfacing ability of the various functionalities that are there. So this we have already discussed. So that's why what I've done is I've just brushed through the various phases. Now just see. This is a very simple pictographical representation of V and V-shaped model. So here the first phase in V and V-shaped model that we have is product and requirement planning. So product and requirement planning is a phase where all the requirements are identified and resource allocation is done. Now this particular phase is allied with production, operation and maintenance, because during production, operation and maintenance, what is required is that the knowledge of the various requirements that are identified is required, right? So this is very much important. So then what we have is we have product requirement and application analysis. So in case of product requirement application analysis, what we tend to do is we tend to look into the various requirements, the implementation of the various requirements, and use of resources. Now, to see, likewise, product requirement and application analysis allied with system and acceptance testing, because in case of system and acceptance testing, what we have is we have the provision for actually accepting or rejecting the product that is actually developed. So that is allied with product requirement specification analysis. Then after that, we have architectural design or high-level design. Now, architectural design and high-level design is allied with integration and and testing. Because in case of architectural design and high level design, what we tend to do is we tend to identify the functionalities and relationship between them, and that is what we do. That is what we test in case of integration and system and testing, integration and system testing, right? So likewise, we have detailed design being allied with unit testing, because detailed design looks upon the algorithm data structure. So we need to always ensure that the correct algorithm and the correct data structure is selected for implementing a particular module. So that's why detailed design is being allied with unit testing. Now, what are the various advantages and disadvantages of this particular model? Now, the advantage of this particular model is that the model is very easy and very easy to use and very simple to understand. This is first and the foremost advantage, because it does not include any feedback part. Now, the second advantage is that the model focuses on verification and validation of not only the final product, but it also calls for verification and validation of all the intermediate products. So this is one of the important achievements of this particular model. Now, here, as verification and validation is carried out early in the life cycle phases, then the probability of generating a very high good quality product increases. Now, the next advantage of a V-shaped model is that V-shaped model always encourages definition of the requirement before the design phase, right? So if the requirements are properly defined before design phase, then it may end up in creating a very desirable system. So, as verification and validation model verifies the outcome of each and every life cycle phase, it also calls for generation of well-defined software standards that each and every life cycle phase is to generate. So, this is also one of the notable advantages of a V-shaped model, right? Okay, and as this model facilitates verification and validation of each and every life cycle phase, then monitoring and controlling the progression of software development also becomes very easy. Now, let's go through a few of the disadvantages. Now, one of the foremost disadvantage of this particular model is that this particular model does not support any iteration or repetition of phase, right? The second disadvantage is that this particular model does not have a risk analysis phase in it, which is neither present in any of the models that we've discussed till now. As this particular model is a very linear model that does not allow for iteration, so it is not capable of handling dynamic changes. And it's in situation where there are changes that are called for during the execution of the life cycle model, then this particular model becomes very difficult to handle, or the model is not capable of handling concurrent activities, right? So now, likewise, when to apply V-shaped model. So, like its predecessors, like the waterfall model, V-shaped model works well only in situation where the definition of the requirement is stable and placed before the design initiation of the design phase. As in situation where you need the assessment of the interim software development standards, like interim intermediate products that are being developed but that are being generated by software lifecycle phases. So if we need assessment of that, then verification and V-shaped or V-shaped model can be used. V-shaped model can be an excellent choice for developing software application in situation where a very high quality software system is required with high degree of reliability and so on and so forth. For an example, hospital management system or like industry management system. So in situation where the reliability and quality call is very high, what we can do is we can use V-shaped model. V-shaped model also works well in situation where whatever is to be implemented is known, and the technology for implementing the system is readily available, right? And the staff is adequately trained. So in such situation, also V-shaped model can be used. So these are the few points that you need to take into consideration when you decide upon using V-shaped model for developing an application. So in today's class, what we have learned about is we have learned about the various models, extending from build and fix model to classical waterfall model to iterative waterfall model to prototyping model and then V-shaped model. So in the next class, we'll be progressing on to rapid application development model and spiral model. So please stay connected. Thank you very much. So do stay safe.